In this video, let's look at your Form 4 App Math textbook, Self Practice 1.4, page 14. Now, let's look at question number 2. For each pair of the function below, obtain an expression in the form of function notation for fg, gf, f squared, and g squared. Now, let's look at part A. Given by the questions, f of x is equal to 3x and g of x is equal to 3 minus x. So we are going to find four composite functions: fg, gf, f squared, and g squared. Okay, now let's find fg of x first. So f of g of x. So if you write like this, g is the first function, f is the second function. So remember, the function which is nearer to the x is the function which comes first. So g is the first function and f is the second function. Now let's focus on g of x first. So I'm going to I write a square bracket here to let you know that now we are focusing on this function g of x. So what I'm going to do here, g of x is equal to 3 minus x, right? So I'm going to replace this by 3 minus x. So f, I will just copy 3 minus x. Okay, so this is f. Now, for the next step, you need to be more careful. Given by the questions, f of x is equal to 3x. So if inside the parentheses, if you see 1 here, I'm going to write 3 times 1. For example, f of 1 is equal to 3 times 1. f of 2 is equal to 3 times 2, and so on. Now, f of x is equal to 3x. So what I'm going to do here is I write the 3 and replace the x by a parenthesis. So what I am going to write inside the parenthesis, it depends on what I see inside the parenthesis here. So here I see 3 minus x, therefore I need to write 3 minus x inside the parenthesis. Okay, now just do some expansion. So 3 times 3, you get 9. 3 times negative x, negative 3x. Okay, so f of g maps x to 9 minus 3x. Okay, this is the composite function that we are looking for. Now, let's go to second part. Find the composite function of g of f of x. So as I told just now, the function which is nearer to the x is the function which comes first. So in this situation, f is the first function, g is the second function. Now, let us focus on f of x first. Focus on this first. So f of x is equal to 3x. I'm going to replace this by 3x. Okay, now let's go to g of x. So g of x is equal to 3 minus x, as I told you just now. Replace the x by a parenthesis. So 3 minus, put a parenthesis here. So what I'm going to fill in here, it depends on what I see here. So this is 3x, therefore I need to write 3x. In this situation, actually you don't have to put the parenthesis, it's okay. The reason that I write the parenthesis is to help you to understand it better. Okay, so this is actually equal to 3 minus 3x, right? So the function g of f maps x to 3 minus 3x. Okay, now let's go to the third part. Want to find f squared. So this one you need to be more careful. So some students might do it this way, which is not correct. F of x is equal to 3x. So take this whole thing square and you will get 9x squared. No, this is actually not correct. So if you see f and you have a small number on the top right of this function f, it means that 2 times of this function. So this means that f of x, 2 times of function f. So now let's focus on f of x first. What is f of x? 3x, right? So this one, the first step is pretty simple. We just copy it, replace the f of x by 3x. Okay, so second step, again using the same function 3x. Write 3 and replace x by a parenthesis. What I see inside the parenthesis here? 3x. Therefore, I need to write 3x over here. So my final answer will be 9x. Okay, now let's go to the last one. G of x, 2 times of the function g. G of x. Okay, so now let's focus on g of x. What is g of x? 3 minus x, right? So replace this one by 3 minus x. And then 3 minus x again. 3 minus x. So what I'm going to fill in here? You see 3 minus x over here. Therefore, you need to write 3 minus x over here as well. Okay, then just open up the parentheses. 3 minus 3 plus x. So the answer will be x. So this is a way how do we get the composite function. Now let me try part B. For part B, given by the questions, f of x is equal to 4 plus 2x, g of x is equal to x squared. Okay, now let's find f of g of x first. F of g of x. Let us focus on g of x first, which is x squared. This step majority of the students should be no problem, but you just need to be more careful for the next step. F of x squared. Focus on this one. F of x is equal to 4 plus 2x. So 4 plus 2x. What I'm going to write here, it depends on what I see here. So this is x squared, therefore I need to write x squared. So it's actually equal to 4 plus 2x squared. So f of g maps x to 4 plus 2x squared. Now let's go to find g of f of x. G of f of x. Let us focus on f of x first. So f of x is 4 plus 2x. 4 plus 2x. Now for the next step, you need to be more careful. X squared. X squared. What I'm going to write here, you just copy this, what you see inside the parentheses here. So 4 plus 2x. Okay, just use the formula to help you to do the expansion, which is equal to 16 plus 16x plus 4x squared. If you forget about the formula, you can do it this way. 4 plus 2x times 4 plus 2x. And then just expand it term by term. You will still get exactly the same answer. So this composite function maps x to 16. Okay, let me rearrange the term, make it nicer. 4x squared plus 16x plus 16. Now let's find f squared. So this means, okay, as I told you just now, if you do it this way, which is not correct, 4 plus 2x and you square it. No, this is not a correct way to find this composite function. Okay, this actually means f of x, 2 times of f. So let us focus on the first f of x first. What is this? This is 4 plus 2x, right? So just copy 4 plus 2x. So as I told just now, for the next step, you need to be more careful. Using the same function, 4 plus 2x, 4 plus 2x. What I see here, which is 4 plus 2x, I'm going to write the same thing here, 4 plus 2x. Now just do some expansion over here. 2, 4, you will get 8. 2, 2, you will get 4. So this is actually equal to 12 plus 4x. So this composite function maps x to 14, not 14, sorry, 4x plus 12. Okay, now let's find g of x. So as I told you just now, don't do it this way. If you do it this way, you copy this one, you square it, this is not correct. This means g of x, 2 times of the function g. Let us focus on the first one. What is g of x? X squared, right? Now you need to do one more time. X squared. X squared. So what I should write over here, this is x squared. So eventually you will get x power 4. So you might be thinking, teachers, if I do it this way, it's correct, right? Okay, so something you do it this way, you see the square here, put x squared and square it. You will notice that in this situation, it's correct, but this is just a coincidence. So if f square of x, you do it this way, you will get a wrong answer. Okay? So remember, don't do it this way. For part C, I will let you to try yourself. I will show you part D. So now, g of x is equal to this, which is a fraction, so you need to be more careful. It's easier for us to make mistake. Let's find f of g of x first. Let us focus on g of x. What is g of x? This whole thing, right? So what we need to do, just copy this one inside here. 1 over x minus 1. Now the next step, you need to be more careful. X minus 5. So x minus 5. What I need to write over here, just look at what inside the parentheses here. Just copy it. Okay, now this is 5. It means that 5 over 1, right? So for a fraction, if you want to do subtraction or additions, the denominator must be the same. So therefore, what I'm going to do here is I'm going to multiply the denominator and the numerators by x minus 1. X minus 1. Okay, so this I will just copy 1 over x minus 1. Here I will get 5 times x minus 1 over x minus 1. Now these two fractions having the same denominator, so I can combine them together. Okay, open up the parentheses, 1 minus 5x plus 5. Negative, negative become positive. So okay, 1 plus 5 is equal to 6. 6 minus 5x over x minus 1. And x cannot be equal to 1. Okay, this composite function maps x to 6 minus 5x over x minus 1. And x is not equal to 1. Now, let's find this composite function, g of f of x. So g of f of x. Focus on the first function first, which is f of x. F of x is equal to this. Now the next step, you need to be more careful. 1 over x minus 1. 1 over x minus 1. Actually, you don't have to put the parentheses, it's okay. The reason that I write this parentheses is to help you to understand it better. So this is what I'm going to write here. Just look at what inside the parentheses here. X minus 5, right? So therefore, I need to write x minus 5 here. So you don't have to put the parentheses, it's actually okay. 1 over x minus 6. And x cannot be equal to 6 because when x is equal to 6, here the denominator will become 0 and this function will become undefined. So this composite function maps x to 1 over x minus 6, and x is not equal to 6. Okay, now let's find f of x. As I told you just now, this one you cannot do it this way. Some students might be doing this way. F of x is equal to this, alright? So take this whole thing squared. This is not a correct way of finding the composite function. So what I'm going to do here, f of x is equal to this. And then one more time, x minus 5. X minus 5. So what I'm going to write here depends on what I see inside the parentheses here. As I told just now, you don't have to write the parentheses here, it's actually okay. So you will get x minus 10. So this composite function maps x to x minus 10. Okay, let's try the last one. g of x. Okay, just focus on the first function, which is g of x. So g of x is equal to this, 1 minus x. Okay, so for the next step, you need to be more careful. 1 minus, oh sorry, not 1 minus, 1 over x minus 1. X minus 1. What I'm going to write here depend on what inside the parenthesis here. So this is 1 over x minus 1. So I'm going to copy it, 1 over x minus 1. So in this situation, you don't have to write the parentheses, this is okay. Now, as I told just now, for a fraction, if we want to do subtraction or addition, we have to make sure that they have the same denominator. So this is 1, right? 1 over 1. So what I'm going to do here is, I'm going to multiply this by x minus 1, do the same thing for the denominator. The denominator and the numerator always need to multiply the same number in order to keep it as an equivalent fraction. Okay, so this is 1 over, let me use back blue color, 1 over x minus 1 minus x minus 1 over x minus 1. I just changed the way of writing 1. I cannot change the value. So 1 is actually equal to x minus 1 over x minus 1. Now the next step, you need to be extra careful. So now I'm going to combine these two fractions together. 1 minus x minus 1 over x minus 1. If you do it this way, it's actually not correct. So 1 minus this whole thing. What we need to do here, we need to put a parenthesis here. Okay, now 1 over, so now let me open up the parenthesis. 1 minus x plus 1 over x minus 1. So this is 2 minus x over x minus 1. Okay, 1 divided by this is actually equal to 1 times x minus 1 over 2 minus x, right? We just flip over the numerator and the denominator. And eventually, we'll get this answer. X minus 1 over 2 minus x. Since the x is at the denominator as well, therefore we need to write the conditions. So x is not equal to 2, because when x is equal to 2, the denominator will become 0, which will make this function become undefined. Okay, so this composite function maps x to x minus 1 over 2 minus x, and x is not equal to 2.